Hello friends, welcome to my channel. Let's have a look at problem 2485, find the pivot integer. In this video, we're going to share some analysis by elementary mathematics. So first, let's look at the problem statement and then we do the analysis. Given a positive integer n, find the pivot integer x such that the sum of all elements between 1 and x inclusively equal to the sum of all the elements between x and n inclusively. So return the pivot value x. If no such integer exists, return -1. So here are three examples. So when n equals 8, the output or return is 6. When n equals 1, so obviously the output should be 1. When n equals 4, so that's -1. So here the n actually is between 1 and 1000. But that's not very essential for us, for our method. So here we're going to do some mathematics. Actually for this problem, the coding is not that essential, but here we want to do some mathematical analysis. So the question asks us to find the integer x, which is greater than or equal to 1, such that 1 plus 2 plus up to x equals x plus 1 adds up to n, right? So this is what we want to find. Actually, if we compute the two sums of the left-hand side and the right-hand side, so we can get these two expressions here. We can let the left-hand side and the right-hand side equal. Then we get this 1 plus x times x equals x plus n times n minus x plus 1, right? So n minus x plus 1 is the number of terms in the right-hand side, right? So the left-hand side has x terms. Then this equals to this expression. So then we can get that. So 2x squared equals n squared plus n, right? So x squared equals n squared plus n divided by 2. However, n squared plus n equals n times n plus 1, right? So within n and n plus 1, at least one of the two numbers is even. So actually exactly 1, right? So we can use integer division. So this explains this equality, right? So in other words, x squared is an integer which equals n times n plus 1, integer division by 2. So here the question is that if this expression is a complete square, in other words, it's some numbers square, then such x exists. Otherwise, we just need to return -1 according to the problem requirement. For example, in example 1, n equals 8, we can compute n squared plus n divided by 2, that is 36. So x equals 6. So with that said, I guess we are ready to write the code. So we can write the code in one line. However, let's write with some redundancy to explain the idea. First, the candidate square is nothing but n squared plus m, then integer division by 2, right? So another one we want to compute is the square root, right? SQRT of this candidate square, right? So if this c is an integer, so can be an integer, then we just need to return that integer, otherwise we return 1. So here the trick is that, so we can check if c equals integer c, right? Because c in general is a float number, right? So if we this equality holds, it means that c actually has a 0 decimal part, so less than 1. So we need to return integer c. So this is the return type, right? The return type should be integer. Otherwise, we just need to return -1, right? So this is for this problem. Now let's do a check. So this checks example 1. So now let's do the generic case check. Yeah, it passes all the cases. So here actually the time complexity, the n is not very essential, right? We just need to compute this square root and then compare if it contains only non-zero integer parts. So that's actually not a very good coding problem, but it's some elementary mathematics, but it's good to practice. So with that said, I guess that's about it for this problem. Thank you.